Hello and welcome. Today we're doing a question from LeetCode. This is from LeetCode 75 and it's called the N-th Tribonacci number. So the Tribonacci sequence T of n is defined as follows, where T of 0 is 0, T of 1 is 1, and T of 2 is 1. And any number after that is defined as the sum of its previous three numbers. So given n, we just want to return the N-th Tribonacci number. So example 1, we have n being 4, and in order to find the N-th Tribonacci number, the fourth one, we need to sum up what we have for our third, second, and first value. And we already know what T0, T1, and T2 are. So we have 0, 1, 1. Now we need to find what T of 3 is. And the way to do that is to sum up its previous three numbers. So T of 3 is going to be 2. And from there, we can now find T of 4, which is going to be 2 plus 1 plus 1, which is 4. So our fourth Tribonacci number is going to be 4. Now, example 2, we have n being 25. We would basically be doing this all the way up until n being 25, and we would get this number over here. So step 1 before doing any problem is to walk through examples. If we don't know how to approach a problem, or even if we do, it just helps solidify our logic. So say our input example is n equals 6. We want to find the sixth Tribonacci number. How are we going to do that? We know in order to find the sixth Tribonacci number, we need to sum up what we have at T of 5, 4, and T of 3. But in order to know T of 5, 4, and 3, we need to know those previous three numbers. So what we're going to do is start on the very bottom and just work our way up, building up every single digit in that Tribonacci sequence until we get to n being 6. So what I'm going to do is first define my T of 0, T of 1, and T of 2. So in a sequence, I'm going to store a list of 0, 1, and 1. Now I'm going to loop through from 3 onwards, so for I in range 3 to n plus 1, because this is not going to be inclusive, I'm just going to sum up the previous three values from I and append that to my sequence list. So it's going to be sequence.append what we have in sequence of I minus 3. And actually I'm going to change this. I'm just going to write this seq so I don't have to keep writing this out every single time. It's going to be what I have in that list from I minus 3 plus what I have in that list from I minus 2 plus sequence of I minus 1. So we're summing up the previous three numbers in our list and adding that to the end of the list. And in the end, we just want to return what we have at index n. So with n being 6, how would this play out? The first thing I do is define my sequence over here. So I have 0, 1. I'm going to loop through from range 3 to n plus 1. So my first n is going to be 3. And I'm going to add to the end of this list over here what I have at 3 minus 3, so what I have at index 0, then what I have at index 1, and what I have at index 2. So 1 plus 1 plus 0 is 2, which means I'm adding 2 to the end of this list. Now I'll go back in this for loop. So now n equals 4, and what am I adding up, right? 4 minus 3, so what I have at index 1, 4 minus 2, what I have at index 2, and 4 minus 1, what I have at index 3. So 1, 1, 2, what is the sum of that? That's 4. We're just appending that to the end of our list. Going back in this loop, we're now at n being 5. And again, we're just summing the previous three numbers. So 1 plus 2 plus 4, that puts us at 7. So the fifth Tribonacci number is going to be 7. And going in this loop one last time, it's going to be n being 6. So we're summing 2, 4, and 7, which puts us at 13. And that is what we are going to return, sequence of what we have at index n. Now we can't go back in this for loop because we range from 3 to 7, but 7 is not inclusive. So we stop at 6 and we return what we have at sequence of n. So we're going to return 13 over here. Now, what if our number was either 0, 1, or 2? We're ranging only from index 3 onwards. Well, it doesn't matter. We won't even go in this loop. Our range would be from 3 to 0, 3 to 1, or 3 to 2. And that range wouldn't be accurate, so we wouldn't go in here. And we would just return what we have at these indices anyway. And we defined our base cases to have the correct values in there. So let's go ahead and submit this. And it is accepted. Now talking about space and time complexity. For time, we go through all of our numbers from 0 all the way up to n. So this is going to be an O of n solution. We just loop through n times. And for space is going to be O of n. We're making use of a list that has n elements. So it's going to be O of n for space as well. But is there any optimization we can do for space? Can we do better than O of n for space? If you notice, we're not actually using every single element we keep in our list. We're only concerned with the previous three numbers. So what if instead of keeping a list, we just keep track of 3 variables that we just update at each iteration of our loop? So instead, what we could do is define our 3 numbers, T0, T1, and T2. So T0, T1, and T2 to be 0, 1, and 1. And this time as we loop through, so for I in range of 3 to n plus 1, we figure out what Tn is by summing up T0, T1, and T2. So T0 plus T1 plus T2. And now that we know what Tn is, we can just re-update our values for T0, T1, and T2. So T0, T1, and T2. What values are they going to get? It's going to shift up, so it's going to be T1, T2, and our newly found T of n. And once we exit out of this for loop, all we need to do is return that number we're storing in T of n. But this only works if we're in the range from 3 to n plus 1, so we are going to need some base cases here. If n equals 0, we're going to return 0. And if n is less than 3, then we return 1. So now if we were to submit this, this is also accepted. Now doing a quick walkthrough with this just to see how those 3 variables play out, say n is 6 again. So we're going to have n being 6, and the first thing we do is make a check. N is not equal to 0, so we don't return. N is also not less than 3, so we don't return 1 here. All we do is define our T0, T1, and T2. So now we've defined T0, T1, and T2 respectively. So now all we do is go in our for loop. I starts off at 3, and we're going to have another variable called T of n. So T of n is just going to be what we have in T of 0, 1, and 2. So that means T of n is going to be 2. And we're going to redefine what we have in T0, T1, and T2. T0 is going to get what we had in T1, so this gets 1. T1 gets what we have in T2, so this is also going to get 1. And T2 is going to get what we had in T of n, so this is now going to be 2. We go back in this loop, I is now going to be 4, and we're going to find a new T of n by summing up these 3 values. So 1 plus 1 plus 2 is 4, and we just redefine T0, 1, and 2. This is going to be 1, this is going to be 2, and this is now 4. I is now 5. We find another Tn, so 4 plus 2 plus 1 is 7, and we make the same update, so 2, 4, and 7. Going back in here one last time, I is now 6, we sum up these values, we get T of n being 13, we make the updates, so 4, 7, and 13, and we're going to return what we have in T of n, which is 13, which is exactly what we were expecting when we solved this using a list. But using only 3 variables, we don't actually need a space of O of n. Our space becomes constant O of 1. It has no dependency on how big n gets. We're only ever going to work with these 4 variables. So our overall time and space complexity, for time, we still go in our loop n time, so that's going to be n. But for space, it's now going to be O of 1. So we just went ahead and solved Nth Tribonacci number. If you have any questions with this, of course, let me know down below. I will answer all of them. If this video was helpful, like, comment, share, and subscribe. And as always, I will see you in the next one.